two unknowns. The two unknowns are VB and VC, and we're solving for VC. So let's set this up here. So the way I'm going to do it here is that I'm going to do it the following way. So if I start off with VA, I have 1, 2, 3. Right, so I'm going to go with node VA. I'm going to go, node A gives me 1 over J2 plus minus J2 plus 1/2. VA, then mutuals here will give me 1 over J2 times the quantity square root of 2, angle 135 degrees. And I got VC, 2 is connected to the ground, so then this guy's then going to be minus, wait, did I do that right? Yeah, I did that. Then I get minus J2 times the quantity VC, no current sources, so it's 0. So are these nice numbers? Well, you can see that and that cancel out. So I get 1/2 here. When I look here, that's a constant term, so I got to pull it to the other side. And then I get this guy here, which is a nice term. So when I'm looking at this, so far it's looking pretty good. Now look at that J. What am I going to do with that J? I'm going to bring it up to here. So here's where these tricks with the phasors become important. So I typically do not rewrite things, but I'm going to rewrite it to show you a hand calculation. So if I look at that, first thing that you want to know, they cancel out. So what do I get? I get 1/2 VA. What am I going to do with this term here? Look at that plus sign, plus, so then I have J at the bottom. If I bring J up, it's now negative J. Okay? So when I look at this term right here, I get minus 1 over minus J. So what am I going to do? I'm going to bring those two cancel out, so now I get 1 over J, but then this is the same as minus J over minus J, which then gives me minus J. But that's a phase here. What's this phase? Negative 90 degrees. So what am I going to do with that negative 90 degrees? Wait, I'm sorry, I'm thinking this guy right now. So if you look at this guy, this is minus J. So I'm going to get minus J VC. Then I'm going to take this to the other side here. So then I get the square root of 2 minus 135 over J2 here. Now, look at that J. What I'm going to do, that J is the same as 90 degrees, but when I bring this up, it's negative 90 degrees. So then I get the square root of 2 over 2, gives me 1 over the square root of 2. Then I get minus 135 minus 90. And so the source here is, what is that? 225? Okay. So then I'm going to get 1 over the square root of 2 of 225 degrees. And then I have 1/2 VA minus J VC. Now I did this in my calculator, so we'll see how these numbers come out.
Can you using that Joe next to VC?
Right here?
No, the next line.
Down here?
Is that
Yeah.
2 is attached to that J?
Oh, it is, thank you. So this should be 1/2. Okay, let's go to the next node. If I go to the next node, I'm looking at VC. Node VC. So if I look at VC here, I have two terms, right? I have minus 2J plus minus 2J VC. I have one mutual with VA. And then I have a current source. What's my current source? Well, it's flowing into the node, so it's got to be positive. But what's that guy? We calculated this earlier. So this guy is the square root of 2 of negative 45 degrees. So if I clean this up here, note that this is 1/2 plus 1/2 gives me 1. So that means I have 1 over negative J2. But remember, negative J2 here, negative J is the same as positive J in the numerator. So then this becomes 1 over J, becomes J VC minus VA square root of 2 of minus 45 degrees. So now I have a matrix. So how do I do my matrix? Well, I'm going to set this guy up, so it's going to be 1/2 minus J over 2. And then my source term will be 1 over the square root of 2 with an angle of 225 degrees. And then this guy over here gives me minus 1 J VA VC, and then the source term here is going to be the square root of 2 times minus 45 degrees. So now all I'm going to do now is I'm going to calculate VC. So there's a couple ways to calculate VC. So to get VC, I do what? I take the determinant of this term, and then the right side, I replace these with the VC terms. So it goes like this. So I want VC. So I take the determinant of this guy right here, which will be 1/2 times that, which gives me J over 2, minus the combination of this, am I doing this right?
How did
I'm
you
getting
get?
negative. I'm getting 0.
How did you get just negative VA
Yeah,
and no
that's-
VC?
Negative
Should be
negative. Let's look at that. VA here.
just J.
We're talking about for this guy right here, right? Yeah. Thank you. Oh my goodness, I'm very happy about that. Because my circuit gave me what? 0 for VC. So then this guy here, if that's negative, so this is the same as plus J2, right? If that's plus J2, I'm going to bring the J up, which will give me negative J2. Let me make sure. So I got a, so if I do this, I'm going to get minus J2 times VA. That minus and that minus cancel. When I bring the J up, I get minus J, and then I have the 2.
I think it would be the second term though that would be replacing, isn't it?
Oh, it's the second equation. What did I have here before? 1/2? Thank you. I had a 0 term and I was going like, okay, so now here I go. The determinant, so 1/2 times that gives me J over 2. This cross with the negative sign, negative, negative cancel, I get a negative. So then I get negative J squared divided by 4. But J squared is the same as negative 1, so then this should be J over 2 plus 1/4. So we'll come back to it here in a minute. That's got to be VC. Now, what is the right side? So remember, I take these guys and I replace it with the VC terms. So I get 1/2 minus J over 2. Then I get 1 over the square root of 2. And this is the square root of 2. So I get that determinant. Which is not true. But if I clean this up on this side here, I could see that as I go over here, VC then is then going to be this determinant divided by this guy, which will give me 1/4 plus j over 2. Okay. So if I do this guy, this is where I just punched it into my calculator. I want 1/2, which would give me 1 over the square root of 2 of 45. Minus minus, that's a plus then. So I get plus j over 2 square root of 2 times the angle 225. You know, there's not a lot of cleaning up here. Yeah, I would have, if I do this by hand, this is nasty. But what if you did this by hand? If you were able to get to here and just said, you just made up an answer, oh, he tried to calculate it. He got the wrong answer, but his setup is right. I give you 20 on 20. As long as I see the setup, I don't care about the answer. Am I clear? Yes, sir.
For the VA notes, how do you get the square root of 2 in the bottom?
Where at? VA now?
No, VA.
Oh, because when I multiply that, it's going to be 1/2 times, so the square root of 2 over 1/2. So then I get the square root of 1 over the square root of 2.
You see like 2 lines above is like in the numerator and then I just went to
Yeah, but look at that. This is 2 is the square root of 2 times the square root of 2. So one of the square roots, I have this. That's what I did.
Oh, okay.
So then this guy cancels out with that and I get that.
Well, why did you do that?
Just
Gotcha.
so I don't carry extra terms. I'm just trying to do that. So if you were to put an answer, and what did I get? This is what I ended up getting. So when you calculate this thing, which is messy, I get the square root of 2 minus 45 degrees. So if I was to solve the differential equation for this, then the way I'm going to do this is that I'm going to transform this thing. So I'm going to go from phasor to time-dependent solution. So then that means here that, here I go. So then I take the real part of VC. What's the real part of VC? It looks like this. Remember, this is in phasor form. So it's what? The square root of 2 e to the minus j 45 degrees, which is the real part of square root of 2 cosine. Now I got to put in the omega term here. The omega term is what? 40t. So then I got to put in 40t with a phase angle of negative 45 degrees plus j sine. We're not interested in sine, so I ignore that. So then the solution to this guy is this guy right here. So this guy would be now the voltage of the capacitor. If I was to write this source out, by the way, this would be nasty. Right? Because if we were to write it up in the old language, that's what we would do. Now, I'm over by half an hour. There's a Thevenin problem, but it's exactly the same. I think I should stop because I don't know how much saturation that you have here. Let me tell you where I'm going to be. Today I'm going to be around. I'm on problem 5 on the exam. Problem 5 is taking me longer than what I expected. So I'm hoping to finish the exam a little bit later today. So if you're around, come by my office and I'll give you your exam. If not, I will be around tomorrow all day long. So if I'm not in my office, you can put a little stick in, you can email me, and And then I will be able to just say, hey, be around at this time, and I'll be around at that time. Yes, sir.
What's the plan for Friday?
Damn, I didn't print out the thing. On Friday, I'll give you a little slip of piece of paper with that. And I typically say that I'll supply like all of the meat and stuff like that.
What time is that?
I say noon,
Okay.
right? I say noon. I'm literally expecting to go from here to there, and I'll give you my desk, and I say, if you want to bring some alcohol, you're more than welcome to, okay? If you want to bring something else, that's good. I would say just bring some odds and ends, like maybe, not a huge salad, but maybe a small salad, chips, whatever you want. I know I live on the slough, so it turns out that it gets cool, okay? So you might want to bring a soda.